Recording in progress. Here we go. Anybody think they can pronounce this word? What does that say? Asymptotic, I think. I'm not good at English, so you guys can help me out. What is the root word of this? Asymptote. It says when you work with sequences, you often use something called repeated reasoning. This means that you notice when pattern repeats and think about how a pattern will extend when repeated. All right, so square is shown. Use a ruler, don't use a ruler. All I want you to do is this on yours. Divide this square in half. You got half on this side, right? Now see this rectangle on the right? Divide it in half. Do this in your book. Draw that line. How much of the square is this that I'm pointing at? It's what? Not a third, 1/4. This is 1/4 of the square. That's a half of the square, and that's a fourth of the square. Now, what if I draw another vertical line through here? How much of the square is this that I'm pointing at? 1/8. What if I make a vertical like this, or sorry, a horizontal like this? How much of the square am I pointing at here? 1/16. And then you can keep this going, right? This would be 1/32. This would be 1/64. Then what? What's this little bit right there? 1/what? 128. Man, that's good. 128. And then this little bit right here would be 1/256. Is this square right here getting pretty small? I'd say, yeah. You could fit 256 of these little squares in the big square. All right, so now I want you to do this. I want you to zoom in. So take your fingers like this on your book and wait a minute. What's wrong? Doesn't zoom in, does it? If this was a computer screen, could we zoom in and make this 1/256 just as big as this square? And then could we just start over and keep going? And then when we get to this little tiny square, could we zoom in again to whatever that is, 1/16,000 something, whatever, I have no idea. But then we could start over again. All right, is this thing ever going to equal 0? Is it ever going to make it to no area at all? No, it's never going to do that. And that's because it's kind of like an asymptote. When you divide something by 2 over and over again, you never quite get fully rid of it. So you guys know what asymptotes are. And I kind of like that because it gives you kind of a visual representation of what's really going on. Just think of it as if you were zooming in. Okay. All right, turn to the next page. Right here. This one right here, arithmetic and geometric sequences. Here we go. Let's figure this out. Allison and Beth each receive $10 per week for doing chores for their neighbor. One day, Allison decides to increase her income using her knowledge of exponential growth. She proposes that her payment change to a penny for the first week, and then double each week thereafter. So let's say you're the neighbor. What do you think about Allison's proposal? She doesn't want $10. All she wants is a penny. And then next week, you just give her 2 pennies and so on. If you're the neighbor, what do you think about this? Is this good or bad? It's good, right? She's basically willing to work for nothing. So let's just figure this out. Let's figure out how much money Beth is making each week. First week, Beth makes 10. How much does she make the next week? No. She gets 10, right? She just gets another 10. Write that down in your book. How much does Beth get the week after that? 10. How much does she get the week after that? 10. She just gets $10. Beth wants $10. She doesn't want any pennies. She wants $10. Every week, Beth makes $10. That's fair. It's not a whole lot of chores. She's not doing a lot. She just maybe a little bit of this, a little bit of that. Allison foolishly got the neighbor to give her a penny. How much is Allison getting in week 2? 2 pennies. Week 3, 4 pennies. Week 4, 8 pennies. In week 5, does the neighbor finally have to bust out some bigger coinage? Well, I guess you could still keep paying in pennies, but it probably would be mean, right? Wouldn't you at least, how much is this, by the way? 16 cents. You give her a dime, a nickel, and a penny, right? Still no big deal. Then what? 32 cents, 64 cents. By week 8, she's finally breaking $1, right? $1.28, right? So finally making $1. So how does Allison's income change as the number of weeks increases? What's a good word for what's happening here? Doubles. Write that down. It doubles. That's exactly what's going on. Does Allison's income represent arithmetic or geometric sequence? Allison's income, not Beth. Beth is kind of boring. She's just making $10 every week. But Allison, would you say this is arithmetic or geometric? What's the difference? Arithmetic means you keep adding the same thing over and over again. Geometric means you multiply by the same thing over and over again. What are we multiplying by here? 2. So which one is it? Arithmetic or geometric? Geometric. Write that down. Geometric. It is definitely geometric. Okay, so here we go. We just did this in Algebra 1, actually. Write an equation to represent Allison's income, G of n. Okay, so let's write this down. G of n. I'm going to write it like this. I'm not going to write it like that. G of n. How much money is she making? Well, how much did she start with? How much? How much did she make in week 1? A penny. So write that down. Remember, this is our formula. Y equals A times B to the X. There's our formula for geometric growth. A is the penny. So put 0.01. B is the growth rate. What's happening to her penny and her every single week? What's going on? Times what? Times 2. And then we're going to raise that to whatever the week is. Let's try out our formula. We're going to call this N. Let's try out our formula. In week 3, she made 4 cents, right? So let's try our formula here. What do I put in for N? 3. So on your calculator, everybody go get a calculator. You're going to need one. Go send a friend to get you a calculator. You definitely want one of those today. Go get a calculator. And then type this in, 0.01 times 2 raised to the 3rd power, and tell me what we did wrong. Something went wrong here. What went wrong? .01. Well, I did. I put 0.01. No, that's a good, you might think so, but you're not actually doing that, because what you're thinking about is the growth rate. And if it was like, that's where the 2 is. But see, I said in week 3, we made 4 cents, right? But this clearly says we made 8 cents. Not parentheses. What week? Oh, go ahead. Ooh, -1 on the exponent. What's that going to do? By the way, in this chart, did we start at week 0 or did we start at week 1? We started at week 1. So you have to subtract 1 off of the week, right? So this is, by the way, week 1, how many weeks has she been working? 0. It's like the 0. You could call it 0 week if you wanted to. But yeah, Davey's absolutely right. You need to have x n minus 1, because what does that do? Let's see about week 3 now. So that's going to be 0.01 times 2 raised to the 3 minus 1 power. Now, did we get the 4 cents we were looking for? We did. Okay, so we just fixed our problem. Good. So in other words, we did this because we started in week 1, not week 0. That's why we had to, we're going to call that the Davy. We're going to do the Davy here, the n minus 1, because we're not starting in week 1, we're starting in week 0. We're not starting in week 0, we're starting in week 1. Turn to the next page. Next page. This proves what Davey just said. What's the value of n equals 0? Well, what's 0 minus 1? Nope. What's 0 minus 1? Negative 1. What if we take this to the negative 1 power, right? Because wouldn't 0 minus 1 be negative 1? What do you get? You get, how much money is that? Don't say 5 cents. That's half a penny, right? If you do 0.01 times 2 to the negative 1 power, you get half of a penny. Is she getting paid half of a penny ever? No. In week 1, she made 1 penny. That's like going back to week 0. In week 0, she would have made half a penny, but she never had a week 0. So we don't need to worry about that. So that's what that means. Okay. So in other words, we're not going to deal with that because she's not making half a penny. All right. If the pattern were to continue, how many weeks would it be for Allison to have a greater weekly income than Beth? Well, what week did we end on? We ended on week 8 when she made $1.28. Let's just keep going. What's week 9? Help me out, use your calculator. Take 1.28, 2.56. All right, so 2.56. What about week 10? 5.12. What about week 11? 10.24. Did she finally make more money? She did, because remember, was it Beth? Beth was making $10 a week. It took Allison 11 weeks of work before she finally made the same amount of money as Beth. Everybody said Allison was silly, right? Well, now you're going to see that Allison was not silly. Turn to the next page. Calculate the income that Allison would earn each week of the week given. 15th week. So here we go. Tell me what to type in. What do I start with? Remember, well, tell me what was our formula. G of n was 0.01 or 0.01 times what? Times 2 raised to the n minus 1 power, right? So here we go. 15th week, that's 0.01 times 2 raised to the what power? 15 minus 1. Now I typed in 15 minus 1. Could you make it easier on yourself and just type in 14? Absolutely could. Yep. Either way, on the 15th week, she made $163.84. Is Allison's neighbor happy now about the deal she made? No, she's not. 15 weeks, that's how many months? It's about 4 weeks in a month. So you're talking about less than 4 months later, she's making $163 a week. And her friend is still making $10 an hour or $10 a week, right? What about the 20th week? How much? 5,242. Aha. Anybody having trouble on how to get this? Basically, you're putting a 20 in right there, right? You're raising it to 19th power. 5,000. Oh, 5,000. Does a decimal point make a difference when it comes to money? It really does. Yeah, decimal points make all the difference. Thank you for correcting me. Does that count as a mistake, McLean? No? Okay. How about 24 weeks? How much is she making? Let's see, 0.01 times 2 raised to the 24, so that'd be raised to the 23. $83,886.08. Was Allison the smart one and Beth the not so smart one? Does geometric growth overtake arithmetic just about every time? It does. Okay, and that's why yeah, you want to invest your money in places where your money makes money. Beth was making more money initially. If we were going to graph this, I'm not even going to actually have you graph it, but this would be Beth. Beth is making this amount of money. She starts out with $10 and she makes, oops, you can't see that. She starts out with $10 and she's making $10. And Allison's look like this. She started out making almost nothing, and then it kind of did that, right? Eventually, she ended up making way more money. All right. So exponential is more powerful. Geometric is more powerful than arithmetic. Turn to page 100. M3 100. Okay, here we go. If things can grow, can they also decay? They can. Here we go. Simeon is studying for a big test and is trying to stay awake. He drank a 12-ounce can of Big Buzz energy drink that contains 80 milligrams of caffeine. Have you ever done this? You have? Okay. Just wondering if you guys actually study. Just kidding. I'm just kidding. I didn't mean that. He is wondering how long the caffeine will stay in his system if the caffeine half-life is 5 hours. What does that mean, the caffeine half-life is 5 hours? When you drink a Diet Mountain Dew and you get all fired up because of the caffeine, right? And you're ready to go, does it stay that way forever? No, your body metabolizes the caffeine. And so eventually you lose your caffeine buzz, right? So how long, this just tells you how long it takes half of the caffeine to be metabolized in your body. It takes 5 hours. So half-life is the amount of time it takes a substance to decay to half of its original amount. So how much caffeine remains in Simeon's system after 5 hours? You got a calculator in front of you. Figure that out. Well, let's write an equation. Let's call this y equals what? What's the starting amount? 80 milligrams. And then what do you multiply by in a half-life problem? 0.5, because it's half-life, right? So you can write that as a half. You can write it as 0.5. I'm going to write it as 0.5 because I'm going to be using a calculator for this. And then we are going to raise this to the what power if we want 5 hours. Now, here's where you got to be careful. My Algebra 1 students are doing the same exact thing right now. And this is the part where you got to be careful. If the half-life is 5 hours, and I want to know what's going to happen in 5 hours, then what do I raise this power to? Is it 5? How many half-lives are there in 5 hours? 1, right? Because there's 5 hours in the half-life. So 5 hours later would be 1. So on your calculator, oh, actually, you don't need a calculator for this. What's 80 times a half to the 1 power? 40. Half of 80 is 40, right? So let's fill out our chart down here. 0 time elapsed, we started with 80. That's 0 half-life cycles. After 1 half-life cycle, we're at 40. At 2, we're at what? You don't even need a calculator for this, do you? What's next? 20. 3 is 10, and 4 is 5. And you keep on going and going and going. Okay. All right, now this is what I want you to figure out. Our equation obviously was this: y equals 80 times 0.5 to the n power, where n was the number of half-lives. Most people do not count time in half-lives, though. They count them in hours or days or minutes or seconds. So wouldn't it be more fun to make the same formula? We already know what this one, the initial amount of caffeine in the system was 80. Well, I don't need to, forget this question. I don't even care about that. You already know that it's 80. This is what I want us to figure out. I want to know, what if we wanted to write a formula for hours instead of half-lives? Let's write that formula, because that's something that seems easier. Let's do that. Right. Y equals 80 times 0.5 to the what power? Let's think about this. Back when we were doing this one, it was 5 hours, half-life of 5 hours. We wanted to know in 5 hours, and you figured out that was 1, right? For 10 hours, you figured out that it was 2 half-lives. For 15 hours, you figured out that it was 3. For 20, you figured out that it was 4. What did you divide each of these numbers by to figure out that number? 5. So what are we going to do? We're just going to take, I'm going to call it T for time, and divide it by how much? 5. Ooh, I'm sorry, you can't see that. 80 times 0.5 to the, I'm going to call it T for time, for hours, T divided by 5. So that way we can now do the problem with hours instead of half-lives, because that is easier in my opinion. Okay. So let's turn to page 102. Page 102. Here was our formula we just wrote down. Y equals, I'm going to write it down again, 80 times 0.5 to the T over 5 power. Okay. It says, use technology, that's this, to predict when the caffeine will be completely out of Simeon's system. Does this make sense given what you know about the exponential functions? Explain your reasoning. Okay, so when is Simeon going to have no caffeine in his system? What? Why do you say never? Why mathematically never? What happens when you divide something by 2 over and over and over again? Do you ever get it all the way down to 0? No, you don't. And so the answer to this question is, when will he be rid of the caffeine? The answer is never. He'll never be rid of the caffeine because this is like an asymptote. But like Mr. Vickers has taught you before, is there a difference between mathematical models and reality? Yes, there is. So mathematically, the caffeine will never leave your system. If you don't have any caffeine for 10 years, is there going to be any caffeine in your system? Probably not, no. But I don't know, mathematically, maybe one molecule is still in there somewhere, who knows, but there's not gonna be much. All right. Number 8, approximately when will the amount of caffeine remaining in Simeon's system be less than 1 milligram? Here's where we want to use technology for this. What do you suppose we're going to do? Graph it. So let's do this. Everybody make your window look like mine. I want your X minimum to be 0. I want your X maximum to be 80. For X scale, I'm going to use 10. You can use whatever you want. For my Y minimum, I'm going to go from 0. And Y maximum, I'm going to go to 100. And again, I'm going to make the X scale 10, just so looks a little better. That delta X and all that other stuff on the bottom, don't even worry about that. Now go back up here and type in our equation. This is why this is so easy. Once you get to use the calculator. Does everybody have this part, the window done already? 0 to 80 and 0 to 100. So go to Y equals and type in 80 times 0.5 raised to the X divided by 5. Make sure that the X is in the exponent. It's probably hard for you to see there, and put this up a little more. Hopefully it'll focus. There it is. So you get Y equals 80 times 0.5 to the X divided by 5 power. That way this will be in hours. Now when I hit graph, you're going to see that the caffeine leaves your body pretty quickly, doesn't it? Pretty quickly. So how am I going to figure out when he's going to have less than 1 milligram? It didn't. Does it say something about stat plots being on?
It just says invalid dimension.
Yeah, go to stat plot, do this, hit second, and then the Y equals, it'll go to stat plot, and then go down to choice 4. Just hit plots off, and that usually fixes it. Did it fix it?
No, it just like shut off.
Oh. Yeah, you gotta turn the plots up. Second stat plot. Oops, second stat plot. You got one of those green plots around. There you go. There you go. All right, so hit the trace button. Hit the trace button. And just use the keys. Let's see. Right here, you can see we started out way up here. If I move over here, you can see we started out with a whole lot of caffeine in our system and it's dropping quickly. How far do I have to go until Y says what? 1 or a little less than 1, right? The first time, when's the first time Y says less than 1? Let's see, it's at 1.3. I know this is hard for you to read. That's the first time, and again, I'm going to hold this up so you can, hopefully it focuses a little bit. See how Y, that's the first time it says 0.93. That's the first time. How many hours elapsed? About 32. Yeah. So it looks like about, that means about 32 hours. So in about 32 hours, that's how long it takes. Think you can do that? Okay. Now, either take out a piece of paper or see this whole page over here. I want to give you some notes, but I don't want you to have to take out a piece of paper. Just cross those off. I'm going to give you some notes to put in right there, okay? This is what I want you to do. Do you guys know what I did in my former life before I became a teacher?
Like a sales guy.
I was a sales guy. This is one of the products I sold. This is actually one, I sold all kinds of products, but this is one of the products I sold. It's called Bistolic. And Bistolic is a blood pressure medication. And so I would go around to the doctors and I would convince the doctors that prescribing Bistolic was a wonderful idea, okay? By the way, it says Bistolic. Here it says Nebivolol. Do you know why it has two names? Those of you who are in, how many of you are in health something in here? A bunch of you. Why do drugs have two names? Do you know why? This is called the brand name. Bistolic is like, that's the cool name that I talk to the doctors about. But Nebivolol is what's called its scientific name, because the competitors with Bistolic is what's called a beta blocker. And a beta blocker, it basically slows your heart rate down. It lets your blood pressure kind of mellow out. It just mellows you out a little bit. But there were other beta blockers besides Bistolic. My job as the salesman was to try to get the doctor to prescribe my beta blocker instead of somebody else's beta blocker. There's lots of different medications that treat high blood pressure. Beta blockers are just one of them. There are all kinds of other things. Anyway, Nebivolol was the one that we sold. There was also atenolol, there was metoprolol, there's all kinds of these other generics that worked as well. But you can see Nebivolol, atenolol, metoprolol, see how they all have similar scientific names? That kind of tells you what class of drug they are, okay? So one of the things that my doctors would always ask me is what's the half-life of whatever drug you're selling? So see here where it says full prescribing information. If you click on that, that comes up with what's called the package insert. Anytime you guys get medicine at home, does it have a little tiny piece of paper all folded up in about 20 folds? And you can take it all out and it's a big old piece of paper. It's got tiny little writing that nobody would ever read. You know who actually reads that? Your doctor. Your doctor actually reads all of this stuff. Look at this, this is ridiculous. But if you go down to, let's see, where would it be? Drug interactions. No, that's not it. There it is. It's called pharmacokinetics. There's two different things. I know it's hard for you to read this, but that says pharmacokinetics. There we go. There's pharmacodynamics. That's what the drug does to your body. Pharmacokinetics is what your body does to the drug. Okay, so your body breaks the drug down. And in pharmacokinetics, because if you're a doctor, you would know where to look. Well, first of all, the doctor would ask me. I'm a salesman. I'm supposed to know. But what does it say the half-life is of Nebivolol? Effective half-life of about 12 hours in people who have fast metabolisms. And let's see, 19 hours in poor metabolisms, like people with slow metabolisms, right? Because don't you have some friends that can eat pizza all day long and they stay skinny the whole time? And you look at one cupcake and you gain 5 pounds, right? So some people metabolize fast, some people metabolize slow. So the half-life of Nebivolol is somewhere between 12 and 19 hours. So write that down in your paper that you got a half-life of 12 to 19 hours. And we learned earlier that Bistolic is dosed in 2.5 milligrams, 5, 10, and 20. So what's the real life problem for this? Did you know that drugs like Bistolic are banned from Olympic athletes? Also on the PGA Tour, golfers, like in women's golf, men's golf, if you're caught taking Bistolic or metoprolol or atenolol, you're canned. Why is that? Because beta blockers calm you down, right? Are there some, why would a golfer want to be able to calm down? Yeah, if you've got like a 5-foot putt to make $500,000, might you be nervous? Might your hands start shaking? Yeah, and you know how drugs have side effects? One of the side effects of Bistolic is that your hands stop shaking. You know, when you get nervous, your hands start shaking. If you take a beta blocker, it tends to calm you down and your hands stop shaking. Would that be a good thing if you're an Olympic shooter where you're trying to do archery and you don't want to be shaking while you're holding the bow and arrow up there or whatever? What's that? What if they're already taking it because they have high blood pressure? Then you either, number one, can't be on the Olympic team, or number two, you got to find a different medicine. Because remember how I said there's lots of other things that's lower blood pressure than beta blockers. So you could take an ACE inhibitor, you could take, an antidiuretic, all these different things that will make your blood. So if you're on the Olympic shooting team or you're a professional golfer, you can't have this. All right, so do they drug test the Olympic athletes and the golfers? Yes, they do. So let's just say, we're going to get off the internet and get back on the real world here. Let's just say that the test can detect anything over 1 milligram of bistolic. Okay, or no, not 1 gram, a half a gram, 1/2 gram. Okay, so anything over a half a gram of bistolic, you're off the team. Okay, but you really like bistolic because it helps you. What I want to know is, how long before the test do you have to stop taking bistolic before you pass the test? Is this something Olympic athletes have to actually deal with? It is. So I want you right now to tell me how long until you pass the test. And let's say you take a 10 milligram. That's pretty standard dose for a lot of people, is 10 milligrams of bistolic. Let's say you take a 10 milligram. How long before you're going to pass the Olympic test? All right. You tell me what to type in. This is really just a calculator problem, right? Well, before we type it in, let's actually write the equation. Y equals what? What are we starting with? How much? 10 milligrams. It's a half-life problem, so what are we multiplying by? 0.5. And we're raising this to, oh, remember how I said the half-life was between 12 to 19 hours? We need to actually come up with a number. So let's just say 16 is our number. We'll kind of split the difference. I know that's a little closer to this, but let's say most golfers are old fat guys, so they're going to be a little slower metabolisms anyway. Let's say there's a 16. What do I put for the exponent here? So that I'm not going by half-lives, but I'm going by hours. Remember in our previous problem, what did we use? We used T divided by what? 5, because that was the half-life. So what should we use this time? Excellent, to write T divided by 16. There's our formula, right? We start out with 10 milligrams of bistolic. The half-life is 16, so T divided by 16. All I got to do now is graph it. So do this on your window. This time, let's go from 0 to 80 is fine. That's actually still pretty good. For Y minimum and Y maximum, what do I want the Y minimum is good at 0, but what do I want the Y maximum to be this time, since we're starting with 10 and we know it's going down? Do we want 100? No, we're starting with 10 and it's going down. So let's just start with 10. It's going to go down, right? You can make your Y scale 1. Now just type in our equation, 10 times 0.5 raised to the X divided by 16 power. 10 times 0.5 raised to the X divided by 16. Everybody still with me? Now you just do the same thing you did before, graph. We started out at 10, and there goes our bistolic. By the way, looking at this, bistolic is dosed what's called QD. Does anybody know what any of you medical people know what QD stands for? Who's your teacher for that? What? That's a really good guess, but that's not right. This is once a day. Once a day. What's BID? That's twice a day. And TID is 3 times a day, and so on and so on. So anyway, bistolic is QD, it's once a day. What happens to bistolic after an amount of time? It goes up, it goes down, right? So most of it's gone before you even take the next dose. Is that a good thing for a doctor to know? Yeah, because what if the doctor prescribes it? Why does the doctor care about half-life so much? Because if the doctor prescribes it, what if you take it home? The drugs affect different people different ways. What if you take it home and you start having terrible side effects and you call the doctor, you gave me this medicine, I'm having terrible side effects, right? the doctor needs to be able to tell you how long it's going to be before you stop having side effects. So if the 16 hours is the half-life, the doctor could say, in about a day, you're going to feel fine. If the half-life was 2 weeks, the doctor might say, you're going to be in this for a while, so you better hunker down. But with Bystolic, you could say in about a day, you're going to be fine. So now just trace. All right, we started out with 10 milligrams. When are we going to be able to pass this drug test? We got to get all the way down to what? 0.5. I'm going to pull this up so you can see it a little better. Hopefully it'll focus. All right, so 0.5. Let's see. Keep going, keep going. When's the first time we hit less than 0.5? 69.7. Is that right? Okay, now maybe yours is a little different than mine, and we're just getting close, but mine says 69.7. So that means 69.7 what? Hours. How many days is that? Let's see, 69.7. 69.7 divided by 24. You're looking at 2.9 days. So just to be safe, if you're the Olympic athlete, how long are you going without taking this medicine? At least 3 days, right? Just to be safe, because the test can pick up anything less than 0.5. You don't want to get kicked off the Olympic team. So you need to have at least 2.9 days to make this happen. Okay. All right. Let's cut the recording. We're not going to have an assignment today. But there was something else I was going to tell you. So if you could stop the recording. What else was I going to tell you?